I'm excited to introduce Shreyansh Mehta, CTO and co-founder at Cequence Security. Shreyansh, are you there with us?
Yes, I'm here.
Thank you for being on. Take it away.
All right. Hello again. My name is Shreyansh Mehta, and I'm the CTO and co-founder of Cequence Security. So today I'm going to talk about the imitation game. How do we detect and thwart the automated bot attacks? So before I kick this off, something about Cequence Security itself. We are a venture-backed startup primarily focused on application security. We have an award-winning AI platform that automatically protects your web applications, your web API-based applications from bot attacks as well as vulnerability exploits. And we have a proven leadership team from Palo Alto Networks and Symantec. Me and my co-founder, we come from Symantec and have roots there. Talking about the problem itself, so earlier this year and late last year, we conducted a survey through EMA where close to 200 plus organizations participated, large and small, average size of 500 plus employees, going all the way up to thousands of employees. And these organizations included financial services, retail, high tech, so sort of a mix of a ton of companies with online presence. And what we found out was a good percentage of these companies with their online presence, but a good percent of that traffic was coming in from automation. And these are typically called bots. I mean, they can be good bots, things like your Google crawlers or a Mint or Yodlee scraping financial services. So it could be good bots, but it could also be bad bots. And the kinds of bad bots that we are talking about are bots that are doing application layer DDoS and making the applications unavailable on the site. People creating fake accounts automatically. They could be doing vulnerability scans on the site, doing account takeovers where they have access to millions of stolen credentials in the wild, and they're just trying it out on your site. So bunch of bad traffic actually hitting your sites, and these sites are composed of not just the web presence, but the APIs that are interacting with your mobile apps, your partners, and so on and so forth. And it's not just about the amount of traffic, it's also about the time to detect and mitigate these bad bots on the site. Again, the survey suggested that on an average, it took 6+ days for these organizations to detect bad traffic on their site, especially the bad actors that are hitting their site, because this kind of traffic comes and goes. There could be multiple actors involved. So to detect an attack campaign, on average, it took them 6+ days. And once you detect that there's a campaign going on, to mitigate, it took them another 4+ days. And think about the kind of fraud that can happen during this time when there are automated shopping bots hitting your site, or it could be your competitor scraping for inventory or pricing information, somebody creating thousands of fake accounts on your site. So the amount of damage that it can cause in your site is immense. So let's talk a little bit about how are these bots actually hitting these sites. They are hiding in plain sight and mimic real users. So what do they have access to is 4 different attack components. They have access to tools, things like Sniper, Sentry, MBA. If you've not heard about them, these are black market tools that can automate attacks and attack campaigns across any site, be it your web application, be it your APIs that are exposed, that are out there. So they have access to these tools. They have access to infrastructure because you don't want to attack as a bad guy from a single IP address. You want to actually distribute that across thousands, if not millions, of IP addresses so that it's very hard to detect these kinds of attacks. There are tons and tons of breaches happening on a regular basis, and the bad guys have easy access to those credentials and PII information that they can use for the attack. And then they sort of constantly morph their behavior so that they can hide in the regular traffic and then react to it automatically if they're getting blocked. So these are the four primary components of an automated attack. So let's walk through maybe one or two use cases on these kinds of attacks. So supposedly I'm a bad guy. What I would start with is the easiest place to start with is actually targeting the API. I can go search the web of the exposed APIs that are out there. There's pretty much good documentation available for the exposed APIs. And if there is not, then I can go ahead and deconstruct a mobile app or a web application. How does it actually interact with the site? So that would be my starting point to discover the APIs that are actually out there. The next step would be so to research some certain hacker forums and then go and say, are there existing tools or configurations that I can use? Or if I'm not a sophisticated attacker and I can't build these tools myself, maybe I'll pay somebody to bring a configuration for a particular site that I want to attack. And then what I get is effectively a script with the entire transactions configured in it. That how do you interact and attack an API? And then I using the four attack components, things like a sniper, or I can or a script itself written in Python or headless browsers. I can drive that traffic through sort of hundreds of thousands of residential IP addresses, which are actually compromised home routers or IoT devices, and sort of verify millions of users' credentials that I have access to in that setup. So thinking like a bad guy, this is what a flow would actually look like. So now let's talk a little bit about why are the attacks on like these so difficult to defend. So number one is if somebody attacks over APIs, these APIs are actually stateless in nature. So a single request itself is good enough to make the attack happen. Obviously, you want to try out thousands of or millions of credentials. You'll make multiple requests, but each request is complete a full transaction by itself. And then I don't necessarily need to rely on a real browser to make this happen. I can write my own tool, distribute it, choose the language of my choice, ranging from C, Python, Node.js, you name it, and use that to attack a site. Let's talk about sort of another imitation technique for large-scale distribution. In this case, maybe a sort of a less sophisticated attacker, but still, that attacker has access to millions and if not billions of username passwords from old data breaches. And that's why sometimes financial services force that, okay, you're not allowed to use an email address as a username. But that said, there are tons and tons of online retailers and high-tech companies that still allow email addresses as their usernames, and they are unique enough that you can actually try it out on various different sites and see what kind of hit rate is possible in that setup. Then to hide and look like a real browser, you can simply rotate the user agent string. That okay, this is a Chrome running on Mac or or Firefox running on Windows, and you can actually rotate through those user agent strings. So if you're just accessing the server logs, it's going to look like, okay, they're real users interacting with the site. And then you can actually distribute those globally across sort of compromised residential IP addresses based on compromised home routers and IoT devices. Now, to detect if it's a legitimate user or a crook, it's very hard to detect because in this case, they actually look like they're coming from Comcast and other residential IP addresses. And you just, as a business, simply cannot block these IPs just because you don't know what kind of traffic is actually coming through them. And that way, the attackers can actually mask the location and the identity. So if you're a business just running in the U.S. or even a specific region in the U.S., the bad guys can actually exit out and look like an IP address from that particular region. So it's very hard to just simply block that IP address because you don't want to use to block the legitimate traffic in your environment. Now let's talk about the third technique of scraping. So typically, scraping is conducted over HTTP GET requests. So simply when you're fetching a page, and it could be about scraping pricing information. It could be about scraping inventory. It could be about just even creating a replica site so that you can try to sell fake goods on your site. So there are tons of good bots that are hitting your site as well, right? You don't want to block Google or Bing that are actually crawling your site and then letting good users direct traffic on your site. So bots actually try to mask themselves as legitimate-looking crawlers, and then they're fetching this pricing information or product information to gain competitive advantage or gain market share in their setup. And if you're using some traditional bot detection techniques where you actually have to instrument the web page with the JavaScript on an SDK and then wait for it when actually a post request happens, it is literally ineffective in that setup because the scraping is actually happening on the first request itself. So when you're fetching the page, you're fetching the pricing information right there. There is no post happening of a username, password, or any of those things. The parameters about SKU of the product or the pricing information gets fetched in just from the single request itself. So these are sort of the kinds of attacks that we are talking about that are hitting all these different organizations. So let's talk a little bit about how Cequence fits into the story and how we can help detect and prevent these kinds of attacks. Our approach is a machine learning-based approach, and our platform is what we call as Cequence Application Security Platform. And the idea is without requiring you to change any of your applications, we can discover and analyze all the application transactions that are actually hitting your web servers and web applications. And then we can render a verdict just by looking at those transactions. This could be about the bot defense, which is the business logic abuse and scraping and account takeovers that we are talking about, or it could be about syntactic attacks where application firewall actually kicks in and protects against these kinds of exploits. And we provide a REST API-based information sharing approach where you can take all the data that is coming out of our platform, it's a very open platform, and then push it out to other infrastructure if you want to. I mean, connect your fraud systems or SIMs and other security tools that you might have. Or you can take actions using our product itself, where we provide a range of capabilities from simple blocking, which may be good for application layer DDoS type of attacks, to a very sophisticated honey trap based approach where you can actually fool the bad guys that the attacks are actually going through versus they're never really hitting your backend infrastructure. The way our machine learning actually works is as the transactions are flowing through, we do a single request analysis first. That means looking at a single request and figuring out, is it really coming in from a real browser or is it faking to be one? Is it actually interacting like a real browser? Is it interacting like a real mobile device? Based on the fingerprinting that we have in place. Then we also have an IP threat intelligence feed that figures out where is the traffic actually coming in from. Is it part of a compromised sort of IoT network? Is it a cloud service provider? Has this been part of an attack campaign that we have actually seen in the past, not just in a given customer environment, but the other customers that we have in place that are sharing that network intelligence with us in that setup? Are the username passwords that are being tried, are they part of a stolen credential list which is a sort of a recent or a historic breach that has happened, and they're simply trying it out on another site. So once you've done that single request analysis, then we get to the next phase where we actually do a multi-request analysis, where we are actually dynamically clustering similar transactions and similar behaviors so that we can actually bubble up these patterns. Because all these bot attacks and automated attacks it's not about that single request, but the intent they are trying to achieve by sending hundreds of thousands of requests over a period of a small time, or it could be a sort of a slow and steady attack over a period of weeks or months in certain cases. So once we do this multi-request analysis where we are actually clustering these transactions or requests coming in, we can then automatically do statistical and behavioral analysis, and then followed by attaching an intent to these clusters. Because you could have good bots hitting your site. You could have legitimate crawlers scraping your site. But then being able to identify and differentiate a good bot versus bad bot, what matters is identifying the intent that there's an account takeover, credential stuffing attack happening. So once it goes through that entire flow, the next step is actually attaching a behavioral fingerprint to a transaction so that you can go ahead and mitigate independent of where that request is actually coming in from. So this is how we bring in our machine learning and behavioral analysis to mitigate these kinds of attacks. We have a fairly flexible deployment model. Everything is deployed through containers, so you can deploy our product on-prem in your environment, in the traditional data center, private cloud environment, public cloud environment, or take it, if you don't want to deploy our software, we also offer a SaaS service, so fairly non-intrusive way to deploy our product. And you can actually bake in security into your infrastructure because we don't need to instrument your applications as your applications are actually coming up. They are automatically protected by us as they're exposed to the outside world. Now, talking a little bit about how our customers are actually getting value out of our product. So one of the large retail customers saved $1.7 million by preventing ATOs on their site. In their case, the bad guys actually deconstructed some old mobile apps to target the APIs that were exposed to serve those mobile applications. And typically, the old apps are forgotten and less protected. So the bad guys were using those APIs to do ATOs and then potentially steal loyalty points in that setup. Now, given that you have every organization have many entry points into their organization, they wanted a single platform to prevent fraud and maintain customer satisfaction. And after they brought us in, they saw 97% reduction in ATOs, and with that they were sort of able to achieve ROI multifold actually in sort of a very short period of time. Talking about another social network, in their case, they had a problem with romance scams. This is one of the largest dating platforms that is out there, and their problem was the bad guys were again deconstructing their mobile apps. So this is primarily a sort of a mobile first organization. Most of their applications get rolled out as mobile apps. In this case, the bad guys were actually targeting the dormant accounts, and once they've taken over those accounts, they were using the connections or relationships that they have actually established to then request funds or loan that, I have somebody sick in my family, I need money. And the average loss associated with this kind of a fraud that this organization was seeing is about $12,000. Now, when we came in, we were able to significantly reduce the fraud that was happening. They already had a solution in place, but because it required some sort of application instrumentation, like a JavaScript to inject on the page, or a mobile SDK to get the signals from the endpoint, any uninstrumented pages, the bad guys were using that to get in. So when we came in, we were able to actually bake in security in their DevOps process, and then significantly reduce ATOs that led to romance scam in their environment. So with that, I want to wrap this up and open it up for some questions, if you guys have any.
Absolutely, yeah. Great presentation, really cutting edge stuff here. So we've got some questions for you from the audience. I want to call everyone's attention first to the resources that are on the screen right there. If you hover your mouse over the URLs on the screen, they are clickable. You can actually click on any one of those, including the Bot Defense SaaS 30-day free trial and the Cequence.ai website. So go ahead and click on those if you're interested in that. And I'm going to go ahead and bring up a poll now for everyone in the audience, and that is, what additional information would you like about the Cequence solution? So let's see, first question that came in, they're asking is, what changes do I need to make in the application to try out the Bot Defense SaaS solution?
So the Bot Defense SaaS is pretty easy to try out. In fact, we are offering a 30-day free trial for people who are actually interested right now. All it takes is if you have a CDN or an application that is online, just point the traffic to us from your CDN, and then we can actually upstream it to where your origins are. Your origin servers could be in AWS environment, in Google Cloud, or in a data center. All it takes is change your CDN to point to us, and then we can actually upstream it to wherever your applications are. The other way is, if you don't have a CDN, we have other ways to instrument your load balancers so that you can send the traffic to us. We can inspect it and give a verdict on it.
Okay. Okay, and I think this question is kind of along the same lines. They're asking, are there prerequisites on the technology stack to leverage this tool?
Not really. So we can pretty much be installed in any environment. Like I said, we have a container-based deployment model. What that means is you can take an off-the-shelf hardware like Dell or HP or any appliance of your choice, deploy us on that. All we need is a sort of a Linux stack and deploy containers on top of that. You can be virtual, you could be in the cloud. So there are no prerequisites as such to deploy us. We can be sort of up and running in any environment that you have in place.
Okay, nice. That's That's tremendously flexible. So I like that. It could help every company out there. Next question, they say, we're a large e-commerce site. Can Cequence support and scale up to our needs?
Definitely, yes. So we have a bunch of large e-commerce sites in our portfolio. In fact, even higher volume than that is we have a bunch of social networks in our site as well. So just to give you an idea of scale in those environments, in certain cases we are handling close to 20 gigabits of traffic on an average, Gbps of traffic, and then even that peaks up to 26 Gbps of traffic. And we are handling close to 500 million transactions a day in those setups.
Wow, 500 million transactions per day. Those are some incredible numbers. Okay, next question. Can I connect my other security and fraud systems with Cequence? Are there integrations like that?
Yes. So most of our customers use this open platform that we have actually built out to push out the intelligence that we are generating into other systems. So like I had mentioned earlier, we have a sort of a REST-based interface, so you can push out the intelligence that we are generating. And examples of that is compromised user IDs that we think are part of an attack campaign. We can push it out to your fraud system. You can take the IP addresses that we are generating and then maybe push it to your CDN to block all the way at the edge, if you like. So that is one way to integrate with other systems. The other way to integrate is actually to ingest the information from other security products that you might have in place. It could be a fraud system itself where you want to monitor user IDs or products that get attacked the most using an upload mechanism. Again, we provide using a REST-based interface. So it's a sort of a two-way communication that we have built out, and you can integrate any security system that supports it.
Excellent. Excellent. All right. I like that. Looks like that's all the time we have in our live Q&A. There's a few more technical questions I've left there for you in the queue, but I want to call everyone's attention again. I've brought up the resources page here with the link to the Bot Defense SaaS 30-day free trial. You can go ahead and just mouse over and click on that link. Sharayan, I want to thank you for your presentation. Excellent job.
Thank you, everyone, for your time as well.